Okay, so this is a set of notes on measuring and constructing angles. All right, so in order to get into angles, we first have to get its component part. The first thing we have is what we call a ray. We tend to represent a ray as an arrowhead in geometry, and we give it an endpoint and a point along the ray. And we would write this as ray AC. So you always have to name the endpoint first when you're naming a ray. So the A has to come first, and C can be any other point along the ray. Now, if I have two rays that start at point A, and one goes through C, and the other one goes through B, and they travel in opposite directions, then we say that ray AC and ray AB, note they have the same endpoint, are what we call opposite rays. So definition of opposite rays are two rays that have the same endpoint that travel in opposite directions. Okay, so at this point we have the ability to name an angle, right? So an angle starts with a point and sends one ray in one direction. Okay, so let's call that C, let's call that A, and then we're going to send another ray in another direction, we'll call that B, and this figure is an angle. That point where both rays start, the common endpoint, is going to be called the vertex. Now, generally speaking, these things are called sides. And when we name an angle, we name it by by 3 points. 1 point on one side, 1 point on another side, and then the vertex point in the middle. So we would name this angle CAB. We could also call this angle BAC. It's the same angle, no problem. The A has to be in the middle, though. We cannot call this angle ABC. No, because in that case, A is not the vertex. So don't do that. All right, so let's get rid of that. That's just bad news. Okay, so sometimes if you have this angle, you could call it angle A, but you have to be very careful. If it's the only angle A in the picture, then great, this would work. But let's say I put an angle, little ray D here, AD. Now I have 1, 2, 3 angle A's, and this would be no good. So you can use angle A if it's the only angle A in the picture or in the frame. Okay, so now that we have an angle, we want to be able to talk about how to measure them, and this is using something called the protractor postulate. So this is analogous to the ruler postulate for segments. Basically what this says is it says start with a straight angle, also known as a line. So let's call this A, let's call this O, let's call this B, and have one side of the straight angle point to 0 and have the other side of the straight angle point to 180. And what you should be able to do is pick some point over here and it'll make a ray. Now what we know is that if this is 0 and this is 180, this is pointing to some other value, probably something around 55. Okay, and something over here might be pointing to like 120. Okay, so now we have a way to talk about what these rays are pointing to. So this just formed an angle, and I should be able to find the measure of that angle in degrees. Okay, so let's set up our game again here. I have this as OA, OB. This is pointing to 0, this is pointing to 180, and I suddenly start with an angle. Okay, so let's call this, I don't know, D, and let's call this E, and I want to find the measure of angle DOE. So I look at what this one's pointing to, call that X. Look at what this one's pointing to, call it Y. if I take those, just like I did with a ruler postulate, and subtract them and take the absolute value, now remember, that's the same as this. It doesn't matter because these are just going to be the opposite signs. This is going to give me the measure of that angle. Okay, so that's what the protractor postulate says. So basically what we're doing is we're creating a protractor here, different measurements, and says that if I take what one side points to and what the other side points to, then I will be able to get the measure of that angle. Now, a lot of people, when they actually use a protractor, turn the protractor so that the one point side points to 0. That way the other side just points to the angle measure, because something minus 0 is just the something. Okay, so that gives us a way to measure angles. Okay, so since I've measured angles, I have a way to talk about angles being congruent. Congruent, there we go, angles. So that's this little symbol again here, right? So if I know that the measure of an angle, ABC, is equal to the measure of another angle, DEF. So let's say here is angle ABC, and over here somewhere is angle DEF. And this measures 50 degrees, and this measures 50 degrees. So if their measures are equal, then I can say that angle ABC is congruent to angle DEF. So congruence has nothing to do with where the angles are located. It's just saying that the measure of the two angles is the same. I do have a way to talk about the position of angles. We can call these adjacent angles. And adjacent is just like a fancy word for next to. So let's say I have a drawing like this, and I have an angle AOB, and I have an angle BOC. Then I can say that angle AOB and angle BOC are adjacent. Now what this means is that the two angles share a common ray and have a common vertex. So OB is a common side to both angles. They have no overlap, right? So they can have no common interior points. So if a point's inside this angle, it can't be inside this angle. Okay, and if I have that, then I have adjacent angles, or angles that are next to each other. Okay. Also, when we talked about segments, we had the idea of a midpoint. And here we're going to talk about having a bisector. Bisector, so something that breaks it into two sections of an angle. Okay, so let's say I have the angle PQR, and I carefully draw a point S so that when I take the ray QS, the measure of this is equal to the measure of that. So I have the ray QS in such a way that the measure of angle PQS is equal to the measure of angle SQR. So this means that angle PQS is congruent to angle SQR. So if a ray breaks an angle into two congruent parts, then we say that that ray QS, is an angle bisector. Now, it also, another way of saying that is we can say that ray QS bisects angle PQR. All right, so summarizing, you get a ray, you get opposite rays, and you get angles, right? An angle is named by 3 points, A, B, C. So this is angle ABC, right? The protractor postulate says that if this is pointing to Y and that's pointing to X on my protractor, then the measure of angle ABC is going to be the absolute value of X minus Y, or it could be the absolute value of Y minus X. It's going to give me the same number. If the measure of two angles, so the measure of angle ABC is equal to the measure of angle DEF, we know that these angles are congruent. If two angles are next to each other, like this, we say that they are adjacent. And finally, if I have a ray that cuts an angle into two equal parts, then we say that that ray is a bisector. Okay, so that's the summary of this section. So this is a ray, this is an opposite ray, this gives me an angle. I think we've got it. All right, that boils it all down to like a kind of a postcard.